Hi guys, today we're going to be going over lesson 1.2, Understanding Rational Numbers. So for start off, we're going to have you list 5 integers and their opposites. So I'm just going to give you a few seconds to do this, but this is a refresher from our last exercise. So if you listed something like 5 and negative 5, 4 and negative 4, or even 0 and 0, all of these integers would be opposite integers because they share the same distance from 0 as their opposite. All right, so let's go over some definitions. The definition of an additive inverse is two numbers that have a sum of 0. So for example, negative 1 plus 1 equals 0. Negative 5 plus 5 equals 0. And negative 1,000 plus 1,000 equals 0. So what can we tell? Well, all of these additive inverses are also opposite integers. So that means the additive inverse of any integer will be its opposite integer. So for example, if you want to look at negative 1 billion, then what is the opposite integer of negative 1 billion? Well, 1 billion, and then 1 billion is the additive inverse of negative 1 billion. All right, so let's go over to the definition of a rational number. Now, a rational number is a number that can be expressed as a quotient or fraction of two integers where the denominator is non-zero. So, for example, you can look at a fraction like 3/5, 1/2, or we can even look at a decimal like 2.25, because we can write this as 2 and 1 over 4. We could also write a mixed number like 1 and 1/5 is also a rational number. Finally, we can write 2.3 as a rational number because this can be rewritten as 2 and 3/10. Right? All right, so a repeating decimal is a rational number whose decimal place does not stop but repeat the same number. So for example, 3.33333 continuing, or 3.3 continuing with that little line above there, is a repeating decimal. The way we denote repeating decimals is by putting that little line above, showing that that number that we have underlined repeats. So for example, 2.25252525, that goes on forever, would be written as 2.25 continuing. Now, even a large number like this, 17.178956231789563, could be written as 17.1789563 repeating. So a terminating decimal is a rational number whose decimal places do not stop and do repeat. Whose decimal places do stop but do not repeat. So for example, 2.1 stops. There's nothing that comes after that last one. Same with 2.25, 100.7, and even this long one here, 100.1115263, they all terminate. And what terminating means is it stops at the end of the decimal. So how do we get to a decimal form from fractions? So we're going to use long division. So if we want to look at the fraction 51/12, what we are going to do is we are going to divide 51 by 12. So for starters, we have to find out how many times 12 goes into 51. So 12 goes into 51 4 times. We will get 48. Now this has a remainder of 3. And so as you can see, 12 does not go into 3. So what we're going to do is we're going to put a little decimal point here, put 1 there as well, and then we're going to put that 0 after, because 51.0 is the same as 51. It is also the same as 51.0000, continuing on forever. So now we can bring that 0 down, and we can see how many times does 12 go into 30. Well, it goes in twice, and we would get, twice. And we would get 24. So 24 minus 30 is 6. And we're going to bring down another 0. Now, how many times does 12 go into 60? Well, that goes in exactly 5 times. We would get 60 here, and we would have no remainder. So what is 51/12? That would be equivalent to 4.25. As we could see through long division, that when we divide 51 by 12, we get 4.25. Let's go over some examples. poll is taken and 28 out of 100 students agree the school menu should be changed. So how can we write this fraction in decimal form? Well, let's go over two ways to do it. For starters, let's do long division. So let's divide 28 by 100. So how many times does 100 go into 28? Well, for starters, it goes into 0 times. So we'll put a 0 there, and we'll add our decimal place, and we'll add another 0. So how many times does 100 go into 280? We'll go in twice. We get 200 here, and we have a remainder of 80. So now we're going to add on another 0, and then we want to see how many times 100 goes into 800. It would go in exactly 8 times, and we would get a remainder of 0. So we know that 28 divided by 100 is equal to 0.28, or 28 over 100 is equal to 0.28. Now you guys might have noticed something interesting here, that when we are dividing by a multiple of 10, we simply move the decimal places over. So another way we can look at this is 28 divided by 100 is equal to 0.28. So let's start off at looking at 28. Now since we're dividing by 100, we know that this is 2 multiples of 10, so we're going to move over 2 spots. 1, 2. Moving that decimal place over, so it started as 28, now it is 0.28. So our answer would be 0.28. Now if we were dividing by 1,000, we would move over 3 decimal places. If we were dividing by 10,000, we'd move over 4 decimal places. Basically, as many zeros as you have is how many places you move over. So let's look at some examples here. We want to determine whether these numbers are rational. So let's look at this first one here. Yes, this is a rational number because it can be written as a fraction. We can also see that its decimal place does not go on forever. And a decimal place that goes on forever would not be a rational number. So let's look at B here. 1.5781. Is this a rational number? And again, yes, because we can write this as a fraction. This is equal to 1 and 5,781 10,000ths. All right, what about this number here? Well, no, this is not a rational number. 2.33322211144 ... is not a rational number because these dots right here mean that it does not terminate, so we cannot write it as a fraction. Well, how about 4/5? Yes. 4/5 is a fraction, and all fractions are rational numbers. Now, how about 1.0? Again, yeah, because 1.0 is equal to 1, and 1 is equal to 1 over 1. So we can see that that's a rational number there. Now let's look at this example here. Jose incorrectly says 2 5/8 is equal to 2.58. So we know this is wrong, so let's try to do it correctly. So let's represent 2 5/8 as the decimal. So 2 5/8 is equal to 2, and then we're going to plus 8 dividing into 5. So 8 divided by 5, what do we get here? For starters, we're going to need to add that 0 on so we can have another place and bring that decimal up. So how many times does 8 go into 50? Well, it would go in exactly 6 times, and we would get 48. The remainder of 2, we'll bring down that 0. Add another 0 here. Now, how many times did 8 go into 20? I'll go in twice for 16. We'll have a remainder of 4. And then how many times does 8 go into 40? That goes in exactly 5 times. So we'd get 40 here with no remainder, so we know we were done with our long division. So what is this equal to then? This would be equal to 2 plus 0.625, or 2.625. So that is what 2 5/8 is equal to. So where did Jose go wrong? Well, it looks like Jose simply thought that you could write the fraction as a decimal, but we know that is not true. So 5/8 does not equal 0.58, and that was Jose's error. All right, so here's some practice problems for you guys. So by class tomorrow, I want you guys to solve and write these fractions in decimal form. I'm going to start with 1/2, 2/3, 5 1/5. And then Antara wants to buy 3 1/5 pounds of ham. what is this weight in decimals? And also, explain, if 9.373 is a repeating decimal, is it a rational number? So this is actually 9.373 continuing. So is 9.373 a rational number? Alrighty guys, thank you for following along, and I hope you guys are able to finish that homework or practice problems before class.